Hello everyone, myself P. Jithendar, Assistant Professor in Electrical and Electronics Engineering at MLR Institute of Technology. So in today's class, I am going to discuss about the superposition theorem. So basically we are having the network theorems like superposition and Thevenin's theorem, Norton's and maximum theorem, so etc. we are having. But today's class I am going to discuss about the superposition theorem. So here today's class we are going to discuss about the what is the statement of superposition theorem and what is the procedure involved in the superposition theorem and how we can verify the superposition theorem. Okay, so here the first point. So the first point is we have to discuss about the statement. What is the statement of superposition theorem? So here the statement of superposition theorem is: in any linear or bilateral network contains two or more voltage sources, the total current is equal to the algebraic sum of the incoming currents or the algebraic sum of the outgoing currents. That is the statement of superposition theorem. So in that we have to find out the, suppose if we are having the some element, for example resistor is there. Across this resistor we need to calculate the current by using the superposition theorem. So for example, I am taking the one simple network here. So here I am taking the one simple circuit like this. So here I need to find out the current. So let us take, this is R1 and this is R2 and this is R3 and source is, voltage source is V. So I need to calculate current through R3 resistor by using the superposition theorem. So here the statement states that in any linear or bilateral network. So linear or bilateral networks are nothing but resistor, inductor and capacitor. Okay. So here I am taking only resistors here, R1, R2 and R3. So in this superposition theorem, so we need to calculate the current through this R3 resistor, right? So in that case, so what we need here, I need to find out current through R3 resistor. Okay. So next we will go to procedure. So what is the procedure? The procedure of the superposition theorem is, so in that we are having the some procedure here. Procedure here. So this is the statement. The statement is, in any linear or bilateral network contain two or more voltage sources, the algebraic sum of the total current is equal to the algebraic sum of the outgoing currents. Here is the statement of the superposition theorem. So now we are having the procedure. The procedure of superposition theorem is, so in that the step 1. So we are having the some steps here. So step number 1 is, so first we have to find out. So first we have to find out the total number of loops. So first we have to find out the total number of loops in a given circuit. Okay. So first point is we have to find out the total number of loops. After that we have to give the current directions. Okay. So here the currents. So basically the currents are depends on the total number of loops in a given circuit. Okay. Suppose if we are having the only 2 loops, so we required currents are 2. If you are having the 3 loops, the required currents are 3. Okay. So here step number 1 is, first we have to find out the total number of loops in a given circuit and we have to give the current directions through each and every element. That is step number 1. And step number 2 is, suppose circuit we are having the voltage sources, 2 voltage sources like this. So we are having the voltage source like this. So this is plus V1 and this is voltage is V2 and resistor is R1 and resistor is R2 and resistor is R3. So here step number 2 is we need to short circuit. So we need to short circuit the secondary voltage source. Then we need to find out current through this R3 resistor or we need to find out current through R1 resistor, or we need to find out current through R2 resistor. Okay, that is step number 2. Similarly, what we need to do, so we need to again short circuit the primary source. We need to short circuit the primary source, that is V1. So here V1 is there. So we need to short circuit the primary source, and again we need to redraw the circuit, and also we need to give the current directions again. And similarly, we need to calculate current through this R3 resistor, and this is R1. So all the elements are same only, R1, R2 and R3. So now we need to find out current through R3 resistor. That is, let us take as I3 or IR3. Okay, that is step number 2. Now the step number 3. So here step number 2 is over, and step number 3 is we need to calculate. We need to calculate current through each and every element, or we need to calculate current through R1 or R2 or R3. Okay, and similarly we can repeat the same steps like this. So we need to repeat the same steps. Okay, and finally we have to verify. So how we can verify the superposition theorem here? So according to statement of, that is step number 5, according to statement of superposition theorem, the total current, that is IT, the total current is equal to the algebraic sum of the outgoing currents. The total current IT is equal to, suppose we are having the two currents, so algebraic sum of the two currents, I1 plus I2. So like this we have to verify it. Here is the some procedure of the superposition theorem. So here the procedure of the superposition theorem is, so step number 1. So first of all we need to find out total number of loops in a given circuit, and we need to give the current directions, and here is first one. And second step is we need to short circuit the voltage source. Suppose if we are having the current source, we need to open circuit the current source. So in the given circuit we are having the voltage, means we need to short circuit the voltage source. If current is there, we need to open circuit the current source. Then we need to calculate the response of the each and every element. That is step number 2. And step number 3 is we need to calculate the current through R1, R2, R3, or voltage across R1, R2, R3, or we can also find out power also. Power through each and every element like R1, R2, R3. Again we have to repeat the same procedure, and after that we have to verify the statement, that is IT is equal to I1 plus I2. So this is the procedure of superposition theorem. And now I will take one example here. So this is, I am taking the one example. So we are having the circuit, primary voltage is 28 volt. So primary voltage is 28 volt and secondary voltage is 7 volt. And we are having the elements, that is 4 ohm and 1 ohm and 2 ohm. So here is the question, we need to calculate current through 2 ohm resistor by using the superposition theorem, right? So here, so we are already discussed about the procedure of the superposition theorem. Okay, so here step number 1. So step number 1 is, so first we have to find out the total number of loops in a given circuit. So in the given circuit, total how many loops are there? So we are having the 2 loops here. This is loop 1 and this is loop 2. First loop and second loop. So we are having the total loops in a given circuit. That is step number 1. So we are having the 2 loops. So 2 loops means the required currents. The required currents are 2. That is I1 and I2. The required currents are I1 and I2. Okay. So step number 1 is, first we have to find out the total number of loops in a given circuit. So in the given circuit we are having the 2 loops. So here for that required currents are I1 and I2. Now the next one is we have to give the current direction. we have to give the current directions through 4 ohm, 1 ohm and 2 ohm. Okay. So in that given circuit, so first I am taking the first loop here. The first loop is, it is starting from positive. So this is plus and minus. So it is starting from the plus, means first loop is clockwise direction. First loop current direction is clockwise, and second loop current direction is, here is plus and here is minus. So the second loop current direction is anti-clockwise direction. Okay. So here first, now we need to give the current through each and every element. So at 4 ohm I am taking current as I1. So first loop current I am taking as I1 and second loop current I am taking as I2. So now the current through 4 ohm, so it is starting from positive terminal, means the current direction is like this. So the current is starting from positive, so I am taking current as I1 at 4 ohm resistor for the first loop, and second loop current is I2. So I2 current is anti-clockwise direction. So the current direction is anti-clockwise, means the current direction is like this. So current through 1 ohm is I2. Now I1 current and I2 current, these two current I1 and I2, so these two currents towards this point. From this point the current is downwards. The current is flowing through the 2 ohm resistor. In that case I am taking current as I3, that is equal to I1 plus I2. This is the total current of the given circuit. So current through 2 ohm, that is I3 is equal to I1 plus I2. Okay. So here is the current direction. Now the next step, that is second step, is we need to short circuit. We need to short circuit the secondary voltage source. Then we need to find out current through each and every element, or the current through 2 ohm resistor. Okay. So here I need to redraw the circuit here. So I need to short circuit. In the circuit we are having the voltage source. We need to short circuit the voltage source. If the circuit contains current source, we need to short circuit the we need to open circuit the current source. So here voltage is there, so we need to short circuit the voltage source, right? And the remaining all the elements are same only, plus minus. This is 28 volt and this is 4 ohm and this is 1 ohm and this is 2 ohm. Now for this new circuit we need to give the new current directions. So previous current directions are I1, I2, I3. Now for this new circuit we need to give the new current direction. So at 4 ohm already we are taking I1. Now here I am taking current as I1 dash. I am taking current through 4 ohm is I1 dash, and current through 2 ohm is I am taking as I3 dash. Similarly 1 ohm. So 1 ohm the second loop is clock. Now it is a clockwise direction. So previously it is a anti-clockwise direction because the secondary side we are having the voltage source. But in the second circuit, there is no secondary voltage. So only we are having the single source. So means first loop is clockwise direction and second loop also clockwise direction. So we have to take the clockwise direction current, that is current through 1 ohm is I2 dash. Okay. At 4 ohm current is I1 dash, at 1 ohm current is I2 dash, at 2 ohm current is I3 dash. Now we need to calculate current through each and every element. So current through 4 ohm, current through 1 ohm and current through 2 ohm. Okay. So in this circuit we have to use mesh analysis, we have to use nodal analysis, or we have to use Kirchhoff laws, or also we have to use the series and parallel combination circuit. Okay. So here by using the series and parallel combination circuit I need to solve the given circuit here. Okay. So here is the second one. So in the second step, so first I need to find out total resistor, that is RT1. I need to calculate the total resistance RT1. So RT1 is equal to, so here the primary voltage source is here. So we have to start from the opposite side, right? So primary source is here. So we have to start from the opposite side. So in opposite side, 1 ohm is there and 2 ohm is there. So these two are connected in parallel. So how we can say these two are in parallel means, at this node point current is dividing. If the current is dividing means the elements are connected in parallel. So here if any two resistors are in parallel, so the equation is 1 by R equal to 1 by R1 plus 1 by R2, or R1 into R2 divided by R1 plus R2. Okay. So now I need to find out the total resistance here, that is RT1 is equal to 1 into 2. 1 into 2 divided by 1 plus 2 plus 4, that is equal to, so RT1, the total resistance RT1 is equal to 1 into 2 divided by 1 plus 2 plus 4, that is equal to, will get 4.66 ohm is the total resistance of the given circuit. Okay. Now in this circuit we are having the total current. So the total current of the circuit is I1 dash. The total current of the circuit is I1 dash. So now we have to find out the I1 dash here. So I1 dash means according to Ohm's law. According to Ohm's law, current I equal to V by R. So already we know Ohm's law, V equal to I into R. So from that V equal to I into R, Ohm's law. So from this Ohm's law, current I equal to V divided by R. Okay. So by using this equation, so we have to find out the total current of the given circuit, that is I1 dash. So I1 dash equal to, so primary voltage V1 divided by RT1, that is equal to, so V1, so V1 means 28 and RT1 means 4.66. Okay. So here the total current of the circuit is I1 dash is equal to V1 divided by RT1, that is 28 divided by 4.66. So here we'll get 6 amperes, that is I1 dash. Now similarly we need to find out the I2 dash as well as the I3 dash. So that is current through 1 ohm and current through 2 ohm. So now, so I1 dash is nothing but current through 4 ohm resistor, that is total current of the circuit. Now the current through 2 ohm resistor. So current through 2 ohm resistor, that is I3 dash. So I3 dash is equal to, so here we have to use the current division rule. So current division rule is nothing but total current into opposite element divided by sum of the individual elements. Okay. So here we need to find out current through 2 ohm. Here we need to find out the current through 2 ohm resistor, means we have to find out the I3 dash. So I3 dash is equal to, so total current of the circuit. The total current of the circuit is I1 dash. So let us write I1 dash into, so 2 ohm is there. So the opposite element of 2 ohm is I1. The opposite element of 2 ohm is 1 ohm divided by the algebraic sum of the two elements, that is 1 plus 2, that is equal to, so I1 dash. So I1 dash means we are getting 6 ampere. So 6 into 1 divided by 3, that is equal to 2 amperes. This is current through I3, current through 2 ohm, that is I3 dash. So current through 4 ohm, that is I1 dash is over here, and current through 2 ohm I3 dash is over. Now we need to calculate current through 1 ohm, that is I2 dash. So here the current through 1 ohm, that is I2 dash equal to, so here also we have to use the current division rule. So that is total current is I1 dash into, the opposite element of 1 ohm is 2 divided by 1 plus 2, that is equal to, so the total current I1 dash is nothing but again 6 ampere. So 6 into again 2 divided by 3, so that is equal to 4 amperes. Okay, so this is I1 dash, I3 dash and I2 dash. So I1 dash is 6, I3 dash is 2, I2 dash is 4. Suppose if we can add I3 dash and I2 dash, will get I1 dash current, that is 6 amperes. Okay, here is the case 1, and in next case we need to short circuit the primary voltage source, and we can repeat the same process here. So here now we have to short circuit the primary source. So primary source is 28 voltage source is short circuited, and here is the circuit. So primary voltage is 7 volt, elements are same 4, 1 and this is 2, right. Now for this circuit also we need to give the new current direction. We need to give the new current directions here. Here is the third one. Okay, so here we are taking first loop current is I1 and second loop, this is second loop current is I2, right. In this case we have to take the same currents here. First loop current is I1, second loop current is I2. Now in previous case, in previously we are taking I1, that is at R1 is I1, at 1 ohm it is I2, at 2 ohm is I3. Similarly in second case, at 4 ohm I1 dash, at 2 ohm I2 dash, at 1 ohm I1 I2 dash and at 2 ohm is I3 dash. Similarly here also at 1 ohm I2 double dash, at 4 ohm I1 double dash, at 2 ohm I3 double dash. Now here also we need to find out the total resistance, total currents and individual currents. Okay, so here in this third step, the total resistance, I am taking total resistance, that is RT2. Total resistance of the second circuit RT2 equal to, so here source is here, so we have to start from the opposite side. So in this case 4 ohm and 2 ohm, these two are connected in parallel. This parallel circuit in series with 1 ohm means 4 into 2 by 4 plus 2 plus 1. Okay, so here the second circuit 4 into 2 divided by 4 plus 2 plus 1, that is RT2. Now RT2 is equal to, will get 2.33 ohm will get, that is RT2 value. Now similarly we have to find out the total current of the circuit. Now in this circuit the total current is I2 double dash because it is from the source. So I2 double dash is equal to, here also we have to use the Ohm's law. I2 double dash is equal to secondary voltage V2 by RT2, total resistance of the circuit, that is RT2, that is equal to V2 7 divided by 2.33. So here also we have to use the Ohm's law. So Ohm's law, I is equal to V by R, that is equal to V2 divided by RT2. So V2 is 7 volt and RT2 is 2.33. So here we'll get 3 amperes. Here is the total current of the circuit, or we can also say current through 1 ohm. current through 1 ohm, that is I2 double dash is equal to 3 ampere. Now we need to find out the individual currents, that is current through 4 ohm and current through 2 ohm. Now here I am taking current through 2 ohm. Current through 2 ohm is I3 double dash. I3 double dash, that is equal to, so here also we have to apply the current division rule. So I3 double dash is equal to total current of the circuit. So total current of the circuit is I2 double dash. So I2 double dash, total current of the circuit is I2 double dash into, so at 2 ohm, the opposite element is 4 ohm, that is 4 divided by 2 plus 4, that is equal to, so already we are calculated I2 double dash, that is 3 into 4 divided by, so 4 plus 2, 6 to 2, that is equal to 2 amperes. So current through 2 ohm resistor is 2 amperes, right? Similarly, we have to calculate current through 4 ohm. So current through 4 ohm, that is I1 double dash, that is equal to, here also we have to apply the current division rule. The total current of the circuit is I2 double dash into the opposite element. So for the 4 ohm resistor, for this 4 ohm resistor, the opposite element is 2 ohm. So 2 divided by 2 plus 4, that is equal to 3 into 2 by 6. So 3 2s, 2 to get cancelled, will get 1 ampere. Here also you can see, if we can add I3 dash, and I1 dash, will get the I2 double dash. So you can see, if 2 plus 1, 3 amperes. So if you can add these two, we'll get the total current, that is 3 ampere. Okay, here is step number 3. And the last step, step number 4 is, so according to statement of superposition theorem, the total current is equal to the algebraic sum of the individual currents. That is, we have to find out I1, I2 and I3. Now here we have to compare first circuit and second circuit. So in that first circuit, I1 direction and I1 dash direction both are in same way. Means we have to write I1 is equal to I1 dash, and we have to compare first circuit, this first circuit with third circuit. So I1 double dash is opposite, minus I1 double dash. Okay, so I1 is equal to I1 dash minus I1 double dash. Similarly, I2. So compare I2, compare first circuit and second circuit. So I2, this I2 and I2 dash both are opposite direction. So I2 is equal to minus I2 dash. And similarly, compare first circuit and third circuit, that is I2. First circuit is current direction I2, anti-clockwise direction, and here anti-clockwise direction. So both are in same direction, means plus I2 double dash. Similarly, current through 2 ohm I3, current through 2 ohm I3 dash, current through 2 ohm I3 double dash. These three are in same way. So means I3 is equal to I3 dash plus I3 double dash. Okay, so this is the according to superposition theorem. So that is equal to, let us take the values. I1 is equal to I1 dash. So the I1 dash value, so 6 ampere, minus I1 double dash value. So already we are calculated, that is 1, equal to 5 amperes. Similarly, I2 value. So I2 equal to I2 dash. So I2 dash value is 4. So we are having 4. So that is minus 4 plus I2 double dash. I2 double dash is 3. That equal to minus 1 ampere. And similarly I3. So I3 equal to I3 dash plus I3 double dash. So I3 dash. What is I3 dash value here? So I3 dash is there. That is 2 ampere. So 2 plus I3 double dash. So I3 double dash is 2. That is equal to 4 amperes. Okay. So these are the individual currents values I1, I2, I3. So I1 is equal to 5 ampere, I2 is equal to minus 1 ampere and I3 is equal to 4 amperes. Right. So, but in the question they are asking calculate current through 2 ohm resistor by using the superposition theorem. So here we need to calculate current value. Means I3 is equal to I1 plus I2. So we have to verify the superposition theorem like this. I3 is equal to I1 plus I2. So verification. So here the last one is verification of superposition theorem is I3 equal to I1 plus I2. Now let us take I3. So what is I3 value? 4. I3 is 4 and what is I1 value? 5. Next I2. I2 is minus 1. So plus into minus 1. So that is 4 equal to, so 5 minus 1, that is 4, that is equal to 4. So both are same, means here we have to write hence the superposition theorem is verified. This is the verification of superposition theorem. So what we have discussed today. So we have discussed about the statement of superposition theorem. So here we have discussed about the statement of superposition theorem and procedure or steps. What are the steps involved in the superposition theorem? So next lecture we are going to discuss about the Thevenin's theorem. So thank you.